Example, the single cable supporting an elevator breaks when the elevator is at the top of a 120-meter high building. Letter A, with what speed does the elevator strikes the ground? Letter B, for how long was it falling, or the time? And C, what was its speed when it passed the halfway point on the way down, meaning that's 60 meters from the top and from the bottom? And for how long was it falling when it passed the halfway point? So what is the time when it reached 60 meters below the top? Okay, say for example, um, this is our, or this is the ground. Here, that's the ground, and say this is the top of the building, and let's say um, elevator is anchored outside, so a construction elevator. Okay, so at this point here, the distance of this building, or the height of the building rather, this one towards the ground, is 120 meters. So when this elevator breaks at the top of 120-meter building, it um, somehow moves down. I mean, it goes down. So this is free fall. So, and this is now the final point of the elevator. So this is point A and point B. At point A, since this is the elevator breaks, then there is a free fall of the elevator at point A. Therefore, the initial velocity is 0 because of free fall. It's not being thrown, it's not even charged to certain force, so it is just a free fall. And we're asked to solve for the velocity final, or the velocity of point B, since the velocity of B is also the final velocity of the fall. So according to the problem, what is the velocity when it strikes the ground? Okay, so the given are the initial velocity, the distance, and the final velocity is to be solved. So the formula, let's just write the formula. Final velocity is equal to the initial velocity plus minus acceleration times time. Then we have final velocity squared equal to the initial velocity squared plus minus twice of the acceleration times the distance. Then we have the distance equal to the initial velocity times the time plus minus 1/2 of the acceleration times the time and square. So since there is a given initial velocity, which is 0, and distance, since this is free fall, then the acceleration here is governed by g, or that's 9.81 meter per square seconds. So this time we're gonna decide whether this is plus or minus, or negative or positive. So the distance also is already given. Okay, so let's try to arrive. Final velocity is the velocity at point B, which is the question being asked. And then we have the initial velocity, which is a free fall. Again, this is free fall. Then the distance given is 120 meters as the height of the building. And then the acceleration is g, and we're gonna use the positive sign. Anong positive sign? Because the gravitational attraction is downward. Since that's downward and the motion is downward, it goes together with the direction of the acceleration, so, or gravitational acceleration. Then therefore I'm gonna use the positive sign. So again, when the body moves down, then that's positive g. When the body moves up, then that's negative g. So that's from the previous discussion that I had in the introduction. Alright, so we're gonna solve the final velocity. So final velocity squared, and that's equal to initial velocity, which is 0 square. So obviously this is 0. And then you have, we're gonna use the positive sign. And then twice of the acceleration due to gravity, 9.81 meter per square seconds, and the distance is 120. So therefore, the final velocity is now being solved. So that's the square root of 2 times the 9.81 times 120. So that's 48.522. That's meter per second. So this is the velocity when the elevator strikes the ground. Okay, next question, letter B. For how long was it falling? Okay, for how long was it falling, meaning it is asking for the time. So better yet, we're gonna use this one. Okay, so since we're asked to solve for that, we have the final velocity equal to the initial velocity plus, we're gonna use the plus again because it's free falling. We're talking about the elevator that is falling down. Acceleration times the time. So the final velocity is 48.522, and that's equal to the initial velocity, which is 0, then plus the 9.81 times the time. So the time is 48.522 divided by 9.81. That's 4.946. And that is in seconds. So if you wish to use the other formula like this one, there's no problem with that, as long as you have to supply the necessary element. Say for example, this one here. We're going to use the distance formula. So the distance is 120, and the initial velocity is 0 times the time, which is obviously to be multiplied by 0 is also 0. And then we're going to use the positive sign again. That's 1/2 times the acceleration times 9.81 and square. So therefore, we're going to have 120 times 2 divided by 9.81, and you square that, or you take the square root. So the time is 4.946 as well seconds. So it's really all up to you kung unsa imong gamiton nga formula. Alright, so that's the first question, A and B. Let's proceed to the second one, or the third one. What was its speed when it passed the halfway point on the way down? Okay, so this is halfway point from this point here towards here. So basically this is, so let's call this as 60 meters. So when the elevator is at this particular point, pila kuno ang iyahang velocity. Let's call this as point C, and we call that as VC, and of course we're gonna find the time. Time 1. Okay, so from here we just have to follow again the same concept or the same formula that we used. So we're gonna use this one since we have a given distance and velocities, or initial velocity rather. So we're gonna have the VC, or the final velocity, square. No, VC man siya at this particular point. This is the next final velocity at midpoint. Initial velocity squared. Again, we are going to use the positive, 2 times acceleration times the distance of 60. Okay, so this is the VC squared, and that's equal to the initial velocity plus 2 times 9.81, and the distance is 60 because this is midway. Alright, so this is the square root of the 2 times 9.81 times 60. So this is 34.310 meter per seconds. And of course, the time being used. So we're going to use the final velocity equal to the initial velocity plus the acceleration times time. This one is t1. So VC here, and that's equal to the initial velocity plus acceleration times t1. So the VC, or the velocity at the midpoint or midway, is 34.310, and that's equal to 0 plus the 9.81, and you multiply that with the time 1. Okay, so the time 1, or the time at 60 meters midway, is 34.310 divided by 9.81. That's 3.497. 3.497 seconds. So we have now the idea for this example. So basically, this is just a simple example for a free falling body. So you just have to master the principle or concept of gravity, of free falling and motions upward. Okay,